Hello everyone, this is Ian from Ozone Engineering with a quick video about the Eccentricity ACT in Ansys Maxwell. This is a really useful tool for rotating devices that lets you simulate the effects of imperfections in your motor. Ideally, everything would line up perfectly on axis, but sometimes things get misaligned, which can cause some seriously negative effects. We're going to talk about how to model it. Before we do, let's cover the basic types of eccentricity. Static eccentricity is when the motor axis is shifted from the stator axis, but the rotor still rotates around its own axis. Dynamic eccentricity is when the rotor axis is off-center, but the rotor is still rotating around the stator axis. There's also a mixed eccentricity, which is a combination of these two. Let's start by opening up the Eccentricity ACT from the ACT Extensions menu. If you're going to use this on a 3D model generated from RM Expert, then you'll need to add some user-defined data. Specifically, the one that you need is on screen now, Eccentricity 1. The other value I have here just makes it so that it doesn't apply symmetry. I had RM Expert generate a motor with a really large air gap, that way we could see what's going on here a little bit easier. When you open up the ACT, the project you have open should automatically be selected. If not, just click on the Update button. Once the project is in, you'll see options to set vectors for rotating part and rotation axis eccentricity. When you do this in 3 dimensions, you're going to have another vector for the tilting angle, as well as the z component for your translation vector. As for how these vectors relate to the eccentricity types, if you want static eccentricity, then both eccentricities should be set to an identical value. If you want dynamic eccentricity, then only the rotating part eccentricity should be adjusted. And if you want mixed, then set both eccentricities, but to different values. Click Finish to generate a new model that has the eccentricity motion built into it. In the new model, you'll find variables where you can set the vectors for the rotation and the rotating axis. When you set values for these vectors, you can see the model shift accordingly. Here's an example of a dynamic eccentricity simulation. Notice how, as you would expect, the area with the smallest air gap has the highest magnetic field. For this one, I set a vector on the rotating part, but not on the rotation axis, so because they're mismatched, we've got the mixed eccentricity case. A couple things to note about this method: all of the rotation and the translation are dependent on the design variables it creates. You can adjust these to fine-tune your eccentricity, but any of the coordinate systems that are added should not be adjusted at all. And if your model's already been set up for eccentricity, then don't use the wizard to modify it again. Last thing to keep in mind is that when you're setting up the eccentricity, the positions and directions of all of your moving objects are adjusted based off of the eccentricity settings, which use the original geometry as a reference. So after completing your setup and clicking Finish, all geometries update to reflect these changes. If you need to edit the geometry, you have to do so in the original design and then reapply the eccentricity setup for a new version. That's everything I have to cover in this one. If you have any questions or if there's anything you want to see, let me know in the comments. Otherwise, this has been Ian from Ozone Engineering. Thanks for watching.